Well, hi everyone. Thanks so much for showing up for your math learning today. I remain, as always, your humble math servant, Mr. Jennings, and I invite you to turn to this example. This example is great because even if you don't have the handout package, which I think everyone does, you can copy things down pretty easy. There's not much given. So, Gavin, what do you suppose we do with this piece of information? The radius of the Ferris wheel is 20 meters.
That means it's half a period, doesn't it?
A radius is half the period? So let's start with a little picture. Your face was better than my face. Your face did what my face wanted to do. Okay, so there's a picture of my Ferris wheel. See, there's the axle. This is the R radius. And I sort of have this feeling that this would be like our minimum value. And this would be our maximum value for height. And so what does a radius represent in this situation? Don't whisper. Say it with confidence. Yeah, this is the amplitude. The radius equals the amplitude. So A equals 20 when like the h, the height as a function of time and t seconds is equal to 20 times something. Okay, and it makes a complete revolution every 40 seconds. What can I do with this 40 seconds business? That is the period. Yeah, this is very straightforwardly the period. But the period doesn't show up in a straightforward way inside our functions, right? We got to do some legerdemain to transform it into some transformation value. Which one? How do we do that? Period equals, we got a mini formula, 2 pi over k. But the better mini formula to use here would be k equals 2 pi over the period. So what's our k value in this equation? Just pi on 20, Mr. Jennings. Oh, good job, student who is locked in. Yeah, pi over 20. Because if you have 2 over 40, that's the same thing as 1 over 20. So let's keep going. All right. The initial position on the ride is at the bottom, which is 2 meters above the ground. Okay, so the min equals 2. And this is where we get on. We get on at the 6 o'clock position, like right at the bottom of our Ferris wheel. Cool. Sorry? We're going to use a negative cosine. Oh, that's beautiful, yes. Our negative cosine is going to take us from the winter all the way to summer and back to winter again. Just like this course. Because I'm going to fail y'all, so you have to come back next year. No. We're like 1/2 period of winter to summer together. We're just the rising aspect of cosine this class, right? Yes. Yeah. I'm feeling pretty good about our time together. Okay. All right. So So we want to see the graph of the rider's height for the first 2 revolutions. So I'm going to put in there my ground level, which is h equals 0. And then we have our top. What's the highest that we ever get on this Ferris wheel? 40. The clues abound. I heard a lot of numbers that were said like questions. Now that sounds confident. 42 is right, the right answer. 42 is the right answer to lots of questions. This one, not the least of them, but pretty close. Okay, so there's 42, 22, and 2. These are our like significant times, right? Where we're going to hit a quarter period here. We start there. We're going to curve on cosine up to the midline. Curve on cosine up to the maximum. Curve on cosine down to the midline. And then curve on cosine down to the minimum again, and then repeat it. I've seen some of you make some beautiful cosine sine graphs and things, so I appreciate you. I'm just trying to up-level my own skills here. I think I did a pretty good job. Pretty happy with that. Now let's put some points on there so that we have it, some good stuff labeled. So I'm going to label in orange because it really pops. This is the point 0 seconds, 2 meters above the ground. This is the point 40 seconds, 2 meters above the ground. I think you'll agree. And this is the point, which I didn't quite get, but I was trying to avoid my face over there. 80 seconds, 2 meters above the ground. See how I did that? Just add the period. It's amazing. And then, how do you suppose I'm going to get this one, this one, this one? Someone say it for me. Huh? Divide what by 4? Yeah, so I do my quarter periods. Very good. So this is 10, 22. Okay, 10 is a quarter period. 20, 42. And this is all working like totally visually. 30. Does this seem like a fast Ferris wheel to all of you? Are you visualizing this Ferris wheel? I think people say "wee" on this Ferris wheel. I guess every 40 seconds. It's not slow, but it's not fast. But it's pretty big. Like 20 meters is a pretty big radius, I think. I don't know. I don't have like my benchmark there. Okay, determine an equation. Okay, we already got some good work done starting on that. So we remembered that A was 20, K was pi on 20, and C and D remain to be seen. What about C? 22, very good. We have it just a little bit above the amplitude so that our Ferris wheel doesn't crash into the ground. And then D? 0 is good. If we're using negative cosine. So we have height of T is equal to negative 20 cosine of pi on 20 multiplied by t, not x, t, plus 22. And then, to be honest, I hate the way I wrote that down because some of you punch it that way on your calculator. So this would be better. Put the argument of cosine into brackets, and I would always evaluate that first and then take its cosine rather than writing left to right on my calculator. And I use the equals button several times throughout the process, but you could do it. You could write it from left to right. Just be careful to put the whole argument of cosine into brackets there. Okay, what if we wanted a sine function, positive sine? Pi by 20, brackets, t minus 10. Love it. How did you do that? Yeah, so you worked visually up here, and you saw we have to push that to the right by 10, so we need a negative 10 in there. Lovely. And then check your work in Desmos and find that it's true. Okay, cool. Now, at what times during the first 2 minutes will the rider's height above the ground be 38 meters? Well, this is an excellent question. I know that that's why you all showed up for your math learning today, to answer this exact question. Of course not. Of course, that's a little silly, but it is still the type of question that you want to be able to answer. We're going to work with negative cosine because it's by far our simplest function that we had. So I could write it that way as well, and that's maybe my favorite way of writing it, plus 22. Okay. Now we want to know the times during the first 2 minutes when the rider's height above the ground will be 38 meters. 2 minutes is a little bit awkward. That's 120 seconds. So we are talking about in the first 3 periods. And in the first 3 periods, I expect 2 solutions per period. We should find 6 solutions. So I go up here and I just kind of ballpark it. 38, ballpark it. There's my 38 there. And I'm seeing I get 2 solutions per period. Okay? So, Nothing really surprising here, but what we need to do, we're just going to set the height at some time, we don't know the time yet, equal to 38, and go ahead and solve. Minus 20 cosine of pi by 20, pi t by 20, plus 22. And then peel away the layers of Desmos, one layer at a time. The most dangly, most outer layer, the easiest one to remove is minus 22. So we're going to take away 22 from both sides. To be honest, when I do this, I should take it away from that one there when I write across, but I don't know if I'd lose a mark for that. I certainly wouldn't take one from you, don't worry. Okay, what this is showing us is we want the time where we're 14 above the axis. Yes, Arden?
16, not 14.
Thank you for your participation. Okay, so this is the point where we are 16 meters above the baseline, and then we go ahead and divide away the next dangly layer by dividing by minus 20, both sides. Of course, that minus 20 is multiplying the whole side of the equation, so when we divide it, it disappears entirely. So, on that side anyway, so then we get 16 on minus 20, which is minus 4/5. Thank you for protecting us from minus 7/10, which would have been an unfortunate road to go down. And then, now what's our most dangly, our loosest layer of Desmos that we can now resolve? What next, boss? We're going to cos inverse both sides. So this is to say we now solve the question of what value of cosine, what argument of cosine will produce negative 4/5. All right, so that is to say we cosine inverse both sides. So this goes away. And then, again, no surprises here. You visualize your unit circle. And we are minus 4/5. So cosine is negative on this side of the y-axis. So we should find a solution over here, like that, very, very close to pi, where this is 4 and this is 5, but that's negative. And of course, we have this like triangle of solutions. They're both there, okay? This one is also a solution. So that's a calculator question. So we just calculate or ask it, so clear. 4 divided by 5, but it's negative, equals this, and then I go trigonometry, second function, take the cos inverse of that, and we have 2.49. Oh, really? I thought it was going to be a lot closer to 3.14, although that is pretty close to 3.14. We're plenty of the way there to 1 pi. So that's the positive one. So we have 2.49. So let's write that down. 2.49 is the 9 rounding. Oh no, it's 2.50. Yeah, that's better, 2.50. So 2.5 is fine. 2.5 equals pi t over 20. All right? Now let's go ahead. We found this one, and we are headed towards another solution real quick, aren't we? So we can go ahead and find that one now as well. My favorite way to find this would be to say this is negative 2.5, this one here, but I don't want the before time started solution. I want the after time started solution. So I will do 2 pi minus 2.5 to get my second solution. So I'm just going to go here and turn this into a negative number and add it to 2 times pi. Gives us 3.79. Okay, or 3.79. There's my 2 solutions inside 1 period. Let's go ahead and evaluate for t, because we want to know how many seconds that is. So I've got 1 on my calculator for now, so let's go ahead and we are going to multiply by 20 and divide by pi. Of course, we're doing that because if you multiply this by 20 and divide by pi, it goes pi cancels, 20 cancels, 20 cancels. We're actually doing that to both of these numbers over here. 20 on pi. Ew. Okay, you're going to see me do it beautifully on the calculator. This times 20 divide by pi equals, we're at 24 seconds the first time this happens. Sorry, this is the second time this happens. Yeah, this was this number here. So that one gave us, I'm just going to whoop up here. T equals, that was 34? No, 24.1. 24.1 seconds. And then let's do the 2.5 one. Okay, so we were here, clear. -4 divided by 5 equals this. We're going to go cos inverse. Oh, shoot. I did cos. -0.8 equals this. Trigonometry second function. There we go, cos inverse. There we are, back to that like nice, beautiful, exact-ish value. Multiply by 20, divide by pi, gives us 15.9. We probably would have gotten that with the rounded version. Or 15.9 seconds, okay? And then we go back to our visualization and we're like, yeah, that makes total sense. There's 15.9 seconds, there's 24.9 or whatever seconds that is. 24.1 seconds and 15.9. That makes sense. And then we're just gonna go ahead and rattle off our extra solutions by adding the period several times. So then we might say, 38 meters 15.9 24.1 45 no 55.9 64.1 95.9 and 104.1 seconds after they start this ride. I like asking these questions, like putting on something like they get the perfect view at those times and they want to like set the timer on their camera to snap the picture for them. Add a little detail like that and it gives you a sense of like why we want to be able to do this. Okay, all right, so there you go. So there's that one. So practice. That's it for me today. Any questions about this type of problem? Should we check our work in Desmos? Always check your work in Desmos. Because sometimes, like, I'd be pretty disappointed in myself if I were wrong this time. I have, like, no excuses. I feel like I'm at, like, 110% of my powers today. Minus 20 cosine of pi by 20. Oops, that's not right at all, is it? Yeah, I just need a bracket to force it to do this right. Pi x by 20. Okay, and the bracket plus 22. And then we're going to look at the first, we want to see up to 45 or so. We want to see the first 130 seconds. And we also want to know when is y equal to 38. Oh, it's so beautiful. Let's also check the one we made with sine. We made it rather quickly. We said 20 sine. And if I do here x minus 10, it's not going to be right. Why not? I need this in brackets, yes. There, now it's perfect. Look at that. Oh. So good, everyone. Okay, practice setting up your periodic functions. You don't want to have to go through another winter with me. Okay, sorry, I shouldn't make jokes about your marks. They're funny to me, but not to you.